This is Josh White with JW Math Tutoring. In this video, I'm going to cover some more Desmos operations, including the standard deviation function, an alternate method to solve sum and product of roots problems using lists and regression, and also talk a little bit more about the derivative method for finding the value of a constant in a quadratic equation. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
Josh White with JW Math Tutoring here with another video. It's part of my Ultimate Desmos Guide to Digital SAT Math. This video is going to cover basically the following four things. First, the standard deviation function. That's going to be added to page 1 of the guide. And there is, you can see here, it's basically in the same row as mean and median. There's not going to be an example problem. That's part of the the practice problems, but I will demonstrate how you use the function. The second thing is going to be a new method to solve sum and product of roots problems. It's going to be all the way at the end. It is what I call the list method, and the original method that I covered I now call basically like the factoring or intercept method. So this I'm going to go through, and there are going to be two new practice problems that are part of the the PDF file that has all the practice problems on it. So it's now up to 75 total problems. So I will be going over that. And then after that, I'm going to talk a little bit about the derivative method, which is basically one of the methods that I went over to solve a quadratic equation that has a constant in it, to either have like no real solutions or one real solution or two real solutions. And it also technically is usable for the a quadratic function and a linear function intersecting once. Anyways, the two things I'm going to talk about with respect to the derivative method are first, a shortcut way that you can approach it, so it involves less typing and you don't have to memorize this entire long formula that you see here in step 3. And I'm going to demonstrate that on basically one of the problems from the guide that that's already been solved earlier. And then after that, I'm going to talk a little bit more about the derivative method versus the slider approach, specifically for these problems where you're trying to find the maximum or minimum value for a constant in a quadratic equation to have no real solutions or two real solutions, and basically the advantages and disadvantages of using one method versus the other. All right, so with all that being said, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And now we'll go ahead and get started with the first topic, which is going to be standard deviation. Now, in addition to finding the mean and median of a data set, you can also find the standard deviation of a data set in Desmos. The function you're going to use is STDEVP, which finds the standard deviation of a population. There's a similar function, STDEV, which finds the standard deviation of a sample, but that is not the function that you want to use. You want to use the one for standard deviation of a population. So you can just type it in, and then go ahead and type in all of your, whatever your values are from the data set. So for this data set here, that 2.4223, that's the standard deviation of that. Now, a couple things to mention. First, this is only usable when you actually type out all of the individual values, meaning you cannot use this function when, say, the data is provided in a frequency table or a dot plot. If you wanted to use this to find the standard deviation of data from a frequency table or a dot plot, you do have to spend the time manually typing out all of the individual values based on the frequency that they're in. So depending on how many items there are, it's much quicker to learn the theory of how to compare those than to manually type out, the standard deviation function and then go through each answer choice, typing out 30 numbers or 40 numbers or however many there are in the data set. So just keep that in mind. And the other thing to be aware of is that if you go down here to the keyboard, the function keys, you scroll down here to statistics. Here you can also see mean and median, and then right here, standard deviation of a population, STDEVP. That's what you want. So that's technically another way that you can access them, but it's so much quicker and easier to just go ahead and usually type the function itself in. The list method is in general much simpler and much faster, quicker, easier to type. The way you're going to work is you're going to take the original equation and you're going to type that as a function, meaning f of x equals, and then basically the full equation. So that means, of course, you do need to get everything equal to 0. Then you're going to type basically a regression statement, and it's going to be a list. It's going to have multiple items in both sides. So you're setting and solving up 3 different equations here. The first equation is saying that f of x1 equals 0. x1 is your first solution. Then the second one is f of x2 equals 0. Okay, and x2 is just your second root or solution. And then the third equation would be either the sum of the 2 solutions is equal to whatever expression or number you're given in the problem. So like x1 plus x2 equals 33, or 2k plus 5, whatever it is. Or if it's a product, you would type in x1 times x2 and then set them equal to the product of the root's value. Now, one thing you do need to make sure you do is include the constraint at the end there that you can see of x2 greater than x1. Otherwise, what happens a lot of times is it will default to finding the same number, the same root for x1 and x2. And if it does that, the problem's not going to calculate properly. Now, another thing just to be aware of is if there are more than 2 roots, there's 3, 4, whatever, then you would add on to both sides of the regression statement. So in other words, after f of x2, you would add f of x3. Or if you need it, you would also add f of x4. And on the right side, you would add corresponding zeros for each additional root that you add. And then the last kind of equation that's contained within this, it would be x1 plus x2 plus x3 plus x4, and then the sum or product of roots value on the right side. That wouldn't change, obviously. Now, you might also need to mess with the constraints a little bit, because if you do that, if you have more than 2, then you need to make sure that x1, x2, x3, x4 are all being returned as different values. You don't want 2 of them to be returned as the same value, because again, then it won't calculate correctly. So now let's take a look at a couple more problems that involve finding the value of a constant in a sum or product of roots problem, and we're going to use the list method to solve these. So these are new questions, and you can find them in the same PDF file linked in the description or in the pinned comment. So list method says first thing we do is type the original function as f of x equals, and this should be a k, not an x. All right, so that looks good. Now we're going to do our regression list statement. So this one is technically going to have 3 roots, or 3 zeros, x1, x2, and x3. You could call them a, b, and c if you wanted to instead, if that's easier, if you don't want to worry about the subscripts. And I know that when I multiply them together, they equal 84. Okay? x1 is 0, x2 is 0, x3 is 0. That's the definition of a root. Okay? And then together they are multiplied to give 84. All right, we don't have the correct value of k because it's sending them all to the same value. So let's say I start off doing this. Okay? That fixed part of the problem, but no, actually that should be, yeah, that actually should have fixed everything, because now notice we have 3 different values for x1, x2, and x3. If we multiply them together, yep, they equal 84. So we have the value for k right here. It's 8.5, or 17 over 2. So that's how you could do this entire problem using the list method, as I call it, or the regression list approach for this product of roots problem. All right, now let's look at 75, the bottom problem. So to put this one in f of x equals form, we're going to have to technically subtract over the entire right side. So I'm just going to bring over the k minus 5a and x minus k. All right, next, start a regression list statement. This one's only going to have two roots because it's a quadratic, so we'll call them x1 and x2. Again, you could call them, I guess you couldn't use a here because a is already a separate constant. You could use b and c if you wanted. And we know that the sum of them, so x1 plus x2, and our tilde, the first root is 0. That's what makes it a root. The second root, the y value is 0. So it makes it a root, and then the sum of them is 3k plus 21. Okay, is it giving us the right value for a here? That's what we're asked to find. No, because, again, notice x1 and x2 are identical. They are not two specific unique values. So when I put this in, notice now it actually does work. It gives me two different values for x1 and x2, and a comes out to negative 4.2 or negative 21 over 5. So this is how you could solve this problem, this sum of roots, sum of solutions problem, using Desmos, specifically using the list method or list approach. Next, I want to share a little tip that was sent to me by someone that watches my channel, and it specifically relates to what I call the derivative method. All right, so essentially, most of the time, this is a method that is usually used for, say, finding the value of a constant in a quadratic equation to have either no real solutions or one real solution or two real solutions. Okay, basically that general approach. And again, you can also use it to find the value of a constant for a quadratic equation or a quadratic function and a linear function to intersect only, at one point. All right, so basically the little tip or trick, which could save you some time, is this. Here, the way that you see it written on the screen here, it basically says, for the quadratic equation example, right, you have f of x equals your quadratic function, g of x equals 0, and then you type in that whole long thing with f of x and g of x and so on. Okay, so two things. First, one thing to be aware of, technically g of x does not need to equal 0. You actually can set it up such that f of x equals the left side of the equation and g of x equals the right side. So in other words, you do not, so one thing to be aware of is you do not need to actually move the terms over, and you can still go through the exact same process and it'll work. Okay, that is not the tip. That's actually not the tip that the person shared with me, which I'm going to get to in a second, but that is just one thing to be aware of that, kind of I discovered is you technically don't have to move all the terms over and get it equal to 0. Okay? So just one thing just, to be aware of. Wanted everyone to know that. The second thing is, and this is the tip that was shared with me. Okay, if you do have it set up such that one function is f of x and has all the terms, and another function is g of x and is equal to 0, technically you do not need to type this entire long thing here. You can literally just replace, essentially, the second thing here with just zeros. And in fact, you don't really even need the g of x thing. Okay, so you really only have to type the left side and then just tilde and it'll be 0, 0. Now, related to that, if you have a function, if you have two different functions, right, essentially what you can do, or the shortcut is, rather than say having function 1 f of x equals this, function 2 g of x equals this, and then going through and so on, the point is you do you make one function f of x, and the way you construct that is you do the one function minus the whole entire other function. And then for that new single function, then you just type in this, basically this line right here, and just with the zeros, tilde 0, tilde 0. Okay, So let me show you an example of what I actually mean in terms of this. So we're going to look at question 55 here from the guide. This is a problem I've obviously, already solved, already been through, but here is essentially what what I mean. So say normally you would do, okay, the first function is x squared plus 14x minus 5. And then minus c. Okay, you do have to move the plus c on the left, you have to move that over to the right. Okay, then say the second function is the negative 2x plus 4, the linear function, and then of course plus c, because you do have to move that over, right? Okay, so normally now you would type out the whole long thing with the f of x1, f prime of x1, the g of x1, the g prime of x1. Okay, but you can, but the tip is that you can save some time. You can technically subtract these. So like, I mean, you could just have one function up here and just do this, and then a minus and a giant parentheses and type the second thing. Or an alternate way you could just do is this right here, just make a new function h of x, and then you can do h of x1 comma h prime of x1 tilde 0 comma 0. Okay, so now essentially we have the correct answer. I mean, this is the correct value for c here. And notice if you do it this way, where you graph out both the originals and then make a new one with the subtraction, notice it still visually shows you the intersection of the linear function and the quadratic, on the graph here. So this is just a little, technique that you can use. You don't have to do it this way. You don't have to use this. Again, the advantage is that what you're basically, when you do this, set up this like combined subtraction function, a new function, which is just the difference between the two existing ones. The point is, you don't have to type as much down here, okay? You only have to type, essentially the left side and the right side is just 0. So you don't have to memorize as much to type or, whatever. So if you want to do that, if you want to like use this approach to the derivative method, that's fine. Go ahead and do this. Just wanted to share it with everyone to make sure you were aware. Now, the last other thing I want to talk about here is basically quadratic equations with a constant using sliders versus the derivative method, because most of the guide has generally focused on using the derivative method to find the value of a constant, with no real solution, one real, two real solution, so on. But some problems could be easier with a slider. So I'm going to look at this example problem right here, okay, that you see on the screen. This is not, you're not part of the guide, you're not going to see this anywhere. This is just a little extra, thing I want to talk about, want to demonstrate. All right. So first thing I'm going to do is just, first I'm going to solve this using the derivative approach and just, see how much work it takes to figure this out. So I would do f of x equals left side. I would do g of x equals right side. Technically, I could make them of h instead of x, but I'm just going to use x because I'm used to doing that. Okay, and now I'm going to type the regression list statement. Okay, so a couple things. First of all, so it's given me an answer here, right? It's saying like q equals 12, and it looks like they intersect once where x is equal to 2. Right here, 2 comma 20. Okay, so the question is, all right, what happens, as I move it greater than 12? So let's say I set it to 12. I set the step value to 1. All right, obviously I need to increase this. Okay, so notice as I increase this, there is still a solution. They're still intersecting somewhere, you say like, right here. So now as I decrease this, looks like they are not intersecting, but then eventually they do start to intersect again. and then it's going to go into the negatives, and what happens if we jump up here to negative, I don't know, say 100. Looks like they continue to intersect, even as we get larger and larger negative numbers. So, but notice what just happened when I got rid of that. Notice another value popped up, right? Notice how all of a sudden now it's q equals 4. It's not the q equals 12 that I had earlier. So here, q equals 4. Okay, q equals 12. So it looks like it's actually intersecting at both of these values. So a couple things that I want to mention here. First, a problem like this, where there technically are like two b terms, there's an 8x term here, and then this technically would be, this is like another b term, if you think about x squared plus bx plus c. I would recommend subtracting the right side over and turning this into one function. So for example, you can just do it like this, and then the second thing would just be basically the right side would just be 0. The reason I recommend doing that is because now we can actually see the intersection, like the one real solution much easier, because we're looking at a quadratic with its vertex on the x-axis. Okay, as compared to the other problem, we were looking at technically a quadratic and a line, a diagonal line, meaning not a horizontal line. So the first thing I would mention is, if some of these problems, it's easier, even though you can do f of x equals left side, g of x equals right side, to instead put it all into one function, and then the second function is just 0. Okay, so now we can see, okay, so it found 12 here as the default, right? But it actually turns out that there's another value, which I already saw, it's 4. So again, if we fool around with the slider here, it's up to 20, set our step to 1. Right, notice as you go down here, there's at least 2 real solutions, and it's just going to keep going lower, I think lower and lower and lower. You know what I mean? Like it's not going to flip around is my point. It's, it's just dropping the vertex lower and lower and lower. Okay. And then we come up here, but notice what happens. It's kind of like moving or shifting in a circular pattern almost over to the left. And then notice here at 4, again, it intersects it. So what's actually happening here is there are 2 values where there is exactly one real solution, right? There's the 4, and there's also the 12. And between those, there are no real solutions. And then below the 4 and below the 12, there are 2 real solutions. Okay, so the question's saying, what is the largest possible value of q? Well, it's just going to be 12. All right? Now, maybe it gives you that value initially, but the problem is you don't know it's the largest value until you keep investigating and looking around and seeing what happens, and seeing if there's another value where it's going to touch the x-axis. So the point is, or the key takeaway is here, it might be easier to solve a problem like this with a slider, because there's 2 terms here, there's like an 8x minus a qx, there's 2 b terms is what I mean. The other value is not going to be the opposite of 12, meaning it's not just going to be like negative 12 for the other value. That's what happens when there's only one b term. But here there's 2, and it's like, there's the 8 minus q is technically the coefficient for the b term. You don't know exactly where it's going to be without putting in some type of restriction. So so for this problem, again, it might be easier to just start with q equals 1 here, right? And then set the step value to 1. And first start off, okay, if I go to the left, if I go out, negative here, notice it just looks like it's going to drop down. You could just jump it down here. Yeah, okay, it's disappeared, it's just dropping down. Okay, so let's bring it back up, and then, or let's just jump right back to 1 and see what happens. And notice, okay, right here at 4, here is basically where there's exactly one real solution. And now when I go greater than 4, okay, there are no real solutions. So you might think, okay, well then maybe 4 is the answer, largest possible value of q. For no real, so actually no, it wouldn't be 4, because 4 had exactly one real solution. It would have to be some number bigger than that. All right, so now, let's keep going and see how far does it go. Okay, notice it gets back here on 12. There is one real solution, so that means the largest integer under that, for which there would be no real solutions, would happen to be 11. Okay, so the whole point, or the whole key takeaway of this long-winded, demonstration explanation is, well, there's two things. First, if you have a quadratic, even though you can technically do f of x equals left side and g of x equals right side, and you're looking, and let me just say this, if you have a quadratic and you're looking for a value of a constant for no real solution, one real solution, two real solutions, I still prefer to put everything into one function, meaning to move the right side over to the left, and then f of x equal that, g of x equals 0, and uh, then use either whichever method you prefer, the slider method or the derivative method. The reason being because now you have a quadratic and you're trying to specifically see is the vertex on the x-axis. Okay, so that's the first key takeaway. The second takeaway is some of these problems might be faster or might be easier using a slider. Some might not be because sometimes the numbers, the constants, are very, very, very large. There's one on Blue Book where it's like 289, and you'd have to keep scrolling, moving the slider all the way up to that in order to figure it out. So, on that particular problem, it's probably not faster to use the slider. Probably faster to use the derivative method and then, go from there. But the key point, the second key takeaway is a slider is an option for these kinds of problems. Quadratic equations, finding the value of a constant, no real solution, one real solution, two real solutions, or you can also use the derivative method as well. You should use, what you feel comfortable with, or what is quickest and fastest is easiest for you, when you're solving these types of problems. One last thing to mention, if you're looking to improve your knowledge of Desmos, then please check out my Ultimate Desmos Guide to Digital SAT Math. There are two versions of it now. There's the free version, which is on my YouTube channel. Currently has over 70 practice problems. Covers, all the various topics from your basic core skills up through advanced topics and the various types of regression that you can use to solve constants in the various problems you find at the end of Module 2. And then there's now also a premium version that you can purchase on Udemy. The material in both of the courses is essentially the same. The main advantages to the premium version are that it's ad-free. In other words, you don't have to bother watching ads like you would on YouTube. And I've re-recorded some sections of it and basically rearranged them, especially the advanced skills, so that the common types of problems that have multiple methods are all grouped together. So in other words, all the different methods you can use to solve for a constant in a system of linear equations are all together in one video. And all the different types of methods you can use for solving to find the value of a constant for various types of quadratic problems, are all basically grouped together in one method. So it's organized a little bit better than compared to the original, free version on YouTube, where the problems and the topics that are covered in it are basically just, chronological as I, figure them out or discover them. So in either case, please check out either of those. They're loaded with tips and tricks and basically all the practice problems and skills that you need to ace the digital SAT math section using Desmos.